There is an image from Venus that almost nobody remembers. When Venera 13 landed on Venus in 1982, it did what it wasn't supposed to do. It survived long enough to keep transmitting images. And in those images, something appeared. An object that wasn't in the first frame and was in the next. Over the course of the transmission, several features changed position. One of them appeared to rise out of the soil displaced by the landing itself. It was later nicknamed the Scorpion. Decades later, a scientist who helped design the mission re-examined the raw frames. He asked something more dangerous. Why did we stop looking? In 2012, he suggested the object might not be debris at all. But here's what never happened. We never proved what the object was. We only decided it didn't matter. And that's the real mystery of Venus. Leonid Ksanfomality was a senior researcher at the Space Research Institute of the Russian Academy of Sciences. He had contributed to the Venera missions. He was familiar with the spacecraft, the instruments, and the data. For years after the missions ended, Ksanfomality examined the panoramic images sent back from Venera 13. He was looking for objects or phenomena associated with their appearance, disappearance, or changes in shape. Most analyses of the Venera images had been based on composite panoramas, mosaics assembled from the best parts of multiple photographs. But Ksanfomality examined the individual images separately, looking for differences between frames taken at different times. He found several. In one sequence of images, an object resembling a disc appeared near the upper edge of the frame. The object was about 0.34 meters in diameter. It was regular in shape and seemed to be resting on the planet's surface. Over the course of the imaging sequence, the position and shape of the disc appeared to change. In the first two frames, the shape remained constant. At 72 minutes, a short arc appeared at the bottom of the disc. By 86 minutes, the arc had lengthened, and the disc appeared to be divided into fragments. At 93 minutes, the disc had transformed into a symmetrical bright object formed by numerous angular folds, resembling chevrons. Ksanfomality hypothesized that the apparent change in position might have been caused by heating of the lander, which could have altered the optical axis of the scanning camera. But the change in shape was harder to explain. Another object, which Ksanfomality called a black flap, appeared in the image obtained within the first 13 minutes after landing. The object was vertically elongated, about 60 millimeters in height, and appeared to wrap around a measuring cone used for soil mechanical properties measurements. In subsequent images taken at 27 and 36 minutes, the object had disappeared. But the most intriguing object was the one Ksanfomality called the Scorpion. The Scorpion appeared around the 90th minute after landing in an image taken by the Venera 13:1 camera. It was accompanied by an adjacent object shaped like a semiring on its right side. Before the Scorpion's appearance, the lander had been working for more than an hour and a half. Ksanfomality's first assumption was that the object might be a product of destruction from some part of the lander, but the spacecraft continued to function for a full hour after the object appeared. The systems remained operational, which indicated that no catastrophic failure had occurred. In the earliest images, taken at 7 minutes after landing, a shallow oblong groove was visible in the ejected soil. The groove was about 100 millimeters long. In the image at 20 minutes, the sides of the groove appeared raised, and the length had increased to about 150 millimeters. The orientation of the groove was the same as the orientation of the Scorpion that would appear later. At 59 minutes, part of the regular structure of the Scorpion appeared. At 93 minutes, the Scorpion appeared to have completely emerged from the soil that had been covering it. The soil layer was probably no more than 1 to 2 centimeters thick. Ksanfomality described this as a rescue operation that took about 1.5 hours. He suggested that this indicated the object had limited physical capabilities. By 119 minutes, the Scorpion was no longer visible. Ksanfomality analyzed the technical documentation of the Venera 13 mission. All external operations such as throwing away lens caps and drilling the ground had been completed within the first 30 minutes. Nothing else had separated from the lander after that time. He also emphasized that no retouching or addition of details was applied to the image processing. The observations were based on the raw data. Xanthomality proposed that the lander's impact on the surface had ejected soil in one direction, burying objects that were on the V131 camera side. He speculated that any inhabitants on the V132 camera side might have left the area due to the noise from the lander's pyrotechnic mechanisms and drilling unit, but objects on the other side did not have time to escape and were buried by the ejected soil. He concluded that the physical capabilities of the buried objects were low, which explained the delay in their appearance. In January 2012, Xanthomality published his observations in the journal Solar System Research, which is also known as Astronomiczny Westnik. The response was immediate and overwhelmingly skeptical. So, before deciding what the object was, we need to ask a simpler question. Could anything behave like this on Venus at all? Venus is not just hostile, it is mechanically and chemically destructive. At the surface, the atmospheric pressure is 93 bars, the equivalent of being nearly 1 kilometer underwater on Earth. Any structure, biological or mechanical, must withstand continuous crushing force. The temperature is 464 degrees Celsius. At this heat, zinc melts, organic molecules break apart, DNA denatures. No known biological process can function under these conditions, even for a short time. There is no liquid water on the surface. Any water that once existed has long since evaporated and escaped into space. Without water, every known form of life ceases to operate. This immediately eliminates the possibility of conventional biology, but it also places limits on mechanical explanations. The Venera 13 lander was designed to endure these conditions for minutes, not hours. Its external components were engineered to fail early and cleanly. According to mission documentation, all deployable or disposable hardware lens caps, drilling mechanisms, and external covers completed their operations within the first 30 minutes after landing. After that point, nothing else was designed to move. Yet the Scorpion appeared more than 90 minutes after landing. It emerged slowly, over the course of more than an hour, from soil displaced during impact. Its orientation remained consistent, and then it disappeared. If this was debris, it should have appeared immediately. If it was mechanical, it should have moved quickly, or not at all. Venus does not allow gradual motion. That is the problem. This does not mean the object was alive, but it does mean that both biological and mechanical explanations are constrained by the environment itself, and whatever this was, it behaved in a way Venus should not permit. To understand the explanations offered for the Scorpion, we need to understand the limits of the spacecraft itself. Venera 13 was designed to survive on the surface of Venus for minutes, not hours. Its external components were intentionally simple. Anything that needed to deploy, detach, or move was designed to do so immediately after landing. According to mission documentation, all external operations lens cap, ejection, drilling, and surface interaction were completed within the first 30 minutes. After that point, the lander had no active mechanisms capable of movement. The cameras were passive instruments. They did not move. They did not track objects. They simply recorded whatever was in front of them. Yet the Scorpion appeared more than 90 minutes after landing. If the object was debris from the spacecraft, it should have been visible immediately. If it was mechanical, it should have moved quickly, or not at all. The lander was still functioning. No system failures were detected. Nothing else separated from the spacecraft. Whatever the Scorpion was, it did not behave like a known part of the probe. Engineers familiar with the Venera probes identified the so-called disk as one of the two lens caps ejected from the lander. Rather than a single object that had moved between two places, they were simply two similar-looking objects in different places, one from the front camera and one from the rear camera. The lens caps were famous in the history of the Venera missions. During the Venera 14 landing, which occurred a few days after Venera 13, One of the ejected lens caps landed directly beneath a spring-loaded arm designed to measure the compressibility of the Venusian surface. As a result, Venera 14 ended up measuring the properties of its own lens cap instead of the planet's soil. The other objects that Sanformality described were attributed to image processing artifacts. Scientists who reviewed the original photography noted that many of the features he identified did not appear in the unprocessed data. Jonathan Hill, a research technician at the Mars Spaceflight Facility at Arizona State University, examined higher-resolution versions of the Venera 13 images. He pointed out that if the objects were already on the surface of Venus, the odds that Venera 13 and Venera 14, which landed nearly 1,000 kilometers apart, would both land inches away from similar objects in the same positions relative to the spacecraft were astronomically low. It made much more sense, Hill argued, that the objects were pieces of the lander designed to break off during deployment of scientific instruments. Ted Strick, a photo editor who reprocesses and enhances images from NASA and Soviet space missions, examined the Scorpion image in detail. He concluded that the features Sanformality identified were nothing more than processed noise in particularly poor versions of the images. Strike also noted that Sanformality had used blur and sharpen functions in Microsoft Windows Paint to process some of the images. Sharpening, in particular, can have unpredictable effects on noisy images, creating artifacts that appear to be real features but are actually distortions introduced by the processing itself. The consensus was clear. There was nothing alive in the Venera 13 photographs. The objects were lens caps, image artifacts, and shadows. Sanformality's claims were dismissed as an example of pareidolia, the tendency to see patterns, especially faces or familiar shapes, in random or ambiguous data. And that should have been the end of the story. But let's step back for a moment and consider the broader context. Leonid Sanformality designed thermal, visual, and ultraviolet radiometers for the Mars 3 through Mars 7 missions. During the Venera 9 and 10 missions, he worked on infrared and ultraviolet spectroscopy and imaging, helping to analyze the structure and dynamics of the Venusian clouds. His Groza sensors on Venera 11 through Venera 14 were the first devices to detect intense lightning storms on Venus. He continued his work on infrared spectroscopy and the study of cometary dust, with the Vega mission to Halley's Comet and the 1988 Phobos mission to Mars. In other words, Sanformality was deeply familiar with planetary science, instrumentation, and image processing. He was not someone prone to wild speculation. So why did he publish a paper suggesting that objects in the Venera 13 images might be alive? The paper itself provides some clues. Sanformality noted that the recent discovery of more than 500 exoplanets, most of them hot Jupiters, had encouraged him to question whether scientists were being terrestrial chauvinists in assuming that life can exist only under Earth-like conditions. Hot Jupiter-like conditions, he argued, prevail on Venus. If one accepts the hypothesis that life might exist under such extreme conditions, then it would be premature to assume Venus lacks it. This reasoning is not entirely unreasonable. Scientists have discovered extremophiles on Earth, organisms that thrive in environments once thought to be uninhabitable. These include bacteria that live in boiling hot springs, deep-sea hydrothermal vents, acidic lakes, and even the dry valleys of Antarctica. If life can adapt to such extremes on Earth, why not on other planets? But Venus presents challenges that go beyond mere temperature or pressure. The surface of Venus is not just hot. It is corrosive, crushing, and utterly dry. The atmospheric pressure of 93 bars means that any organism would need to withstand forces equivalent to being nearly 1 kilometer underwater on Earth. The temperature of 464 degrees Celsius is well above the boiling point of water and far beyond the thermal tolerance of any known biological molecule. DNA begins to denature at temperatures above 90 degrees Celsius. Proteins unfold and lose their function. Lipid membranes dissolve. Even the most heat-resistant extremophiles on Earth can survive only up to about 122 degrees Celsius, and those organisms live in hydrothermal vents where liquid water is still present under high pressure. On Venus, there is no liquid water on the surface. Any water that once existed has long since evaporated and been lost to space. The sulfuric acid in the clouds adds another layer of inhospitability. While some extremophiles can tolerate acidic environments, the combination of extreme heat, extreme pressure, and extreme acidity creates an environment that no known form of life could endure. At least, not on the surface. But there is another possibility. At an altitude of about 50 kilometers above the surface of Venus, conditions are very different. The temperature at this altitude ranges from 30 to 70 degrees Celsius. The atmospheric pressure is about the same as at Earth's surface. Solar radiation levels are similar to those on Earth. These are conditions that could, in theory, support life. In fact, the upper cloud layers of Venus are among the most Earth-like environments in the solar system, apart from Earth itself. In 1967, Carl Sagan and Harold Morowitz published a paper in the journal Nature, suggesting that tiny organisms similar to Earth's bacteria might exist in Venus's clouds. They pointed out that water, carbon dioxide, and sunlight, the prerequisites for photosynthesis, are all present in the vicinity of the clouds. This idea has persisted. In 2019, astronomers led by Yeon-Ju Lee reported long-term patterns of absorbance and albedo changes in Venus's atmosphere caused by unknown absorbers. These absorbers might be chemicals, ice crystals, or even colonies of microorganisms. The light absorbance of these unknown particles is almost identical to that of microorganisms in Earth's clouds. In September 2020, a team led by Jane Greaves from Cardiff University announced the detection of phosphine in Venus's atmosphere. Phosphine is a gas that on Earth is produced primarily by biological processes. Its presence in Venus's clouds suggested the possibility of microbial life. The detection was controversial. Subsequent analyses questioned whether the spectroscopic signal was actually phosphine or whether it might be sulfur dioxide instead. Some researchers found no absorption line at all. But the question remained: could there be life in the clouds of Venus? If life could exist in the clouds, could it also exist on the surface? The answer, according to nearly all planetary scientists, is no. The surface is simply too extreme. But Xanformality's observations raise an uncomfortable question. What if we're not looking for the right kind of life? Life on Earth is carbon-based, water-dependent, and relies on specific temperature and pressure ranges. But these constraints are based on the only example of life we know, life on Earth. If life arose independently on Venus, it might not resemble Earth life at all. It might use different chemistry, different solvents, different energy sources. This is not a mainstream view. It is speculative, but it is not entirely without precedent. Scientists have considered the possibility of silicon-based life, ammonia-based life, and even life that uses liquid methane or ethane as a solvent instead of water. These ideas remain theoretical, but they illustrate the limits of our imagination. The truth is, we don't know what life might look like on another world. We can only guess based on what we've seen here. And what we've seen on Venus is a handful of photographs from a handful of landers that survived for a few minutes to a few hours on a planet we've barely explored. So why did we ignore the Venera 13 images? The answer is not simple. Part of it is scientific rigor. Extraordinary claims require extraordinary evidence, and Xanformality's observations did not meet that standard. The objects in the images had plausible explanations as mechanical debris or image artifacts. But part of it is also human nature. Venus has been categorized in the public and scientific imagination as a dead world. Once that categorization is established, it becomes difficult to challenge. There's also the issue of resources. Planetary exploration is expensive and funding is limited. Missions are prioritized based on the likelihood of significant scientific return. Venus, with its hostile surface and thick clouds, is a difficult target. Mars, with its history of water and potential for past or present life, has captured most of the attention. Since the Soviet Venera program ended in the mid-1980s, Venus has been visited by only a handful of missions. NASA's Magellan spacecraft mapped the surface with radar. The ESA's Venus Express studied the atmosphere from orbit. But there have been no new landers, no new surface photographs, no follow-up to the observations made by Venera 13 and 14 more than 40 years ago. The images from those missions remain our only view of the surface, and they are low resolution, heavily processed, and incomplete. We dismissed the anomalies in those images not because we understood them, but because we couldn't afford to take them seriously. That may be about to change. In the 2020s, several missions to Venus are planned or proposed. India's Shukrayan mission, scheduled for launch in the mid-2020s, will carry the first ground-penetrating radar to Venus. This could provide new insights into the planet's subsurface structure and composition. NASA's Da Vinci mission, Deep Atmosphere, Venus investigation of noble gases, chemistry, and imaging is planned for launch in 2029. It will consist of an orbiter and a probe that will descend slowly through Venus's atmosphere, measuring its composition and capturing images of the surface. NASA's Veritas mission, Venus Emissivity, Radio Science, INSAR, Topography, and Spectroscopy, is scheduled for launch in 2031. It will use radar to map Venus's surface in much greater detail than Magellan. The ESA's Envision mission, also planned for 2031, will complement Veritas with spectrometers and ground-penetrating radar. These missions will not land on the surface. They will not take new photographs from ground level, but they will provide data that could answer some of the questions raised by the Venera observations. They might also reveal whether the anomalies we ignored were worth a second look. What happened with the Venera 13 images is a case study in how science works and how it sometimes fails. Science is conservative by nature. It relies on reproducibility, peer review, and skepticism. These safeguards prevent the field from being overrun by false claims and pseudoscience, but they can also prevent genuine discoveries from being recognized. When Galileo first observed the moons of Jupiter through his telescope in 1610, many of his contemporaries refused to believe him. Some even refused to look through the telescope, convinced that what he was seeing was an illusion or an artifact of the instrument. It took years for the observation to be accepted, and it fundamentally changed our understanding of the solar system. The Venera 13 images are not the same as Galileo's moons. The evidence is far weaker, and the explanations for the anomalies are far more mundane. But the principle is the same. We should be skeptical. We should demand evidence. But we should also be willing to revisit old data when new perspectives emerge. Here's what we know for certain. Venera 13 landed on Venus on March 1st, 1982. It survived for 127 minutes. It took photographs. Those photographs showed objects that appeared to change position or shape over time. Most scientists believe those objects were lens caps, debris, or image artifacts. One scientist believed they might be alive. The scientific community rejected that interpretation. The consensus is that there is no life on the surface of Venus. But here's what we don't know. We don't know what causes the unknown absorbers in Venus's clouds. We don't know whether the phosphine detection in 2020 was real or an artifact. We don't know whether life could exist in environments we've never tested. We don't know whether we're asking the right questions. Venus is the second planet from the Sun. It is nearly identical to Earth in size and mass. It once may have had oceans. It once may have been habitable. Something transformed it into the inferno we see today. And in that transformation, something might have survived. Not in the way we expect, not in the places we're looking, but somewhere. The Venera 13 images are not proof of life. They are not even strong evidence. But they are a reminder that we have barely begun to explore the planet next door. We took a few photographs, we made a few measurements, we built a narrative, and then we moved on. For now, the surface of Venus remains hidden beneath its clouds. The photographs from Venera 13 and 14 remain the only ground-level images we have. In a few years, new missions will arrive. They will study the atmosphere. They will map the surface. They will search for signs of volcanic activity, tectonic processes, and chemical anomalies. They might find something unexpected. Or they might confirm what we already believe, that Venus is dead and always has been. Either way, we will learn. But the lesson of the Venera 13 images is not about what we found. It's about what we ignored. We saw something strange. We explained it away. We filed it under resolved and moved on. Maybe that was the right decision. Maybe the objects really were lens caps and shadows. Or maybe we dismissed the first evidence of something extraordinary because we weren't ready to accept it. The universe is full of mysteries. Some of them are waiting to be solved. Others are waiting to be noticed. What we know so far is this: Venus is not Earth. It is hostile. It is ancient. And it is hiding something beneath those clouds. What if we've been looking at the wrong planet all along? What if the questions we should be asking aren't about Mars, or Europa, or Enceladus, but about the world that's been right beside us from the beginning? For now, all we can do is watch, and wait, and wonder whether the Scorpion was real.